Vector store maintenance and data movement. Big idea, one sentence. Vectors go stale fast, so you need incremental updates, change detection, and scheduled refresh pipelines, plus reliable ways to move enterprise data into AWS. Model 1. Why maintenance matters. Exam framing. AWS assumes documents change, permissions change, policies update, duplicates appear, embeddings drift. If your design says rebuild everything every time, it's usually wrong. Incremental updates don't re-embed the universe. What it means, only changed content is re-chunked, re-embedded, re-indexed. Unchanged content is left alone. How it's commonly done. Track document IDs, hash version, compare new versus old, update only deltas. Where this applies, OpenSearch vector indexes, Aurora PG vector tables, managed KB ingestion jobs. Exam signal. If you see, avoid unnecessary recomputation, reduce cost, large corpus, incremental updates. 3. Change detection, know what changed. Change detection answers. Do I need to re-embed this document? Have common mechanisms. File checksum hash, last modified timestamp, version ID S3, CDC for databases. Pattern. Exam trap. Re-embed all documents nightly. Detect changes and update selectively. 4. Scheduled refresh pipelines, time-based hygiene. Not everything is event-driven. Some pipelines run on a schedule, nightly, weekly, monthly. Use cases, compliance reindexing, permission refresh, stale embedding cleanup, re-embedding with a new model. AWS services often used, event bridge scheduler, step functions, glue jobs. Exam signal, periodic refresh, scheduled reprocessing, scheduled pipeline. 5. AWS Static+1, Maintenance Edition. Static, update rules, detection logic, refresh cadence, target vector store. +1, change data, documents records. The rules stay fixed. The data evolves. That's static +1 again. 6, data movement into AWS, enterprise reality. Most enterprise data does not start in S3. AWS expects you to know how it gets there. 7, DataSync, bulk, automated transfers. What it's for, large-scale data transfer. File systems S3 EFS FSX, on-prem or other clouds. Characteristics, incremental sync, preserves metadata, high throughput, scheduled or on-demand. Exam signal, large file shares, ongoing sync, enterprise migration, data sync. 8, transfer family, protocol-based ingestion. What it's for, FTP, SFTP, FTPS access, partners upload files, legacy systems, characteristics. Managed endpoints, auth via IAM or directory, files land in S3 or EFS. Exam signal, partners upload via SFTP, transfer family. Not a 9. How this connects to vector stores, real pipeline. Example flow. You can see the code in our conversation history, or you can see the code in our conversation history. Number 10, classic exam traps. Watch these. Rebuild entire vector DB nightly. Use transfer family for bulk migration. Ignore change detection. Vectors never need refresh. AWS wants controlled movement, not brute force. One memory story. Lock it in. The Office Archive. Incremental updates. Only refile documents that changed. Change detection. Sticky note says updated. Scheduled refresh. Monthly archive review. DataSync, moving filing cabinets into the building. Transfer family, mailroom where partners drop files. No one reprints the entire archive every night. Exam compression rules, memorize. Change data, re-embed. Unchanged data, skip. Periodic hygiene, scheduled refresh. Bulk migration, DataSync. DataSync. Protocol uploads. If the answer reprocesses everything, it's probably wrong. What AWS is really testing. They want to know if you understand that. Retrieval systems are living systems. Designs that don't plan for change don't survive production. Below are clear, production-grade examples you could explain in an exam answer or whiteboard. Real examples. Day 10. Vector store maintenance and data movement. Example 1. Incremental updates for a policy knowledge base. Most common. Scenario, a company has 50,000 policy documents stored in S3, indexed in a vector store, OpenSearch or Aurora PG vector. Every day, a few policies are updated, most stay unchanged. Bad design. Re-chunk, re-embed, re-index all 50,000 documents nightly. Expensive, slow, unnecessary. Correct AWS design, incremental updates. How it works. 1. Each document has document ID, content hash, or S3 version ID. 2. New ingestion run compares stored hash versus current hash. 3. Only documents with changes are rechunked, re-embedded, updated in the vector index. Result: 200 docs changed, only 200 updated. Cost and latency drop massively. Exam signal large corpus, avoid recomputation, reduce cost. Incremental updates. Example 2. Change detection using S3 versioning. Scenario: documents are uploaded to S3 and ingested into RAG. AWS native trick: enable S3 versioning. Store the version ID with each vector entry. Change detection logic: new upload arrives. Compare new version ID with stored one. If same, skip embedding. If different, reprocess. Why AWS likes this: no custom hashing needed, native AWS feature, very exam friendly. Exam takeaway: S3 versioning equals built-in change detector. Example 3, scheduled refresh after embedding model upgrade. Scenario: you switch from Titan embeddings v1, v2, or any new embedding model. All existing vectors are now technically valid, semantically outdated. Correct AWS design, scheduled refresh. What you do: create a scheduled pipeline, weekly or monthly. Re-embed documents gradually. Replace vectors in batches. AWS services, event bridge scheduler, step functions, vector store update jobs. Why this matters: no downtime, no sudden cost spike, controlled migration. Exam signal: new embedding model, periodic reprocessing, scheduled refresh pipeline. Example 4, permission changes without re-embedding. Scenario: a user loses access to a department's documents. Wrong instinct: re-embed documents. Correct design: keep vectors unchanged. Update metadata only, often in DynamoDB or OpenSearch filters. Why? Embeddings don't change, access rules do. Exam takeaway: not every change requires re-embedding. This is a big exam nuance. Example 5, bulk ingestion from on-prem file shares, DataSync. Scenario: a company has 20 terabyte of documents stored on an on-prem NAS, needs them in S3 for RAG. Correct AWS tool, DataSync. Why? High throughput. Incremental sync preserves timestamps and metadata, designed for file systems pipeline. You can see the code in our conversation history. Hack exam signal, large file shares, enterprise migration, DataSync. Example 6, partner uploads via SFTP, transfer family. Scenario: external partners upload documents, daily, using SFTP, legacy systems. Hack correct AWS tool, transfer family. How it works: AWS hosted SFTP endpoint, files land directly in S3, event bridge triggers ingestion pipeline. You can see the code in our conversation history. Exam signal partners SFTP, FTP, transfer family. Example 7, hybrid, DataSync plus scheduled refresh, very realistic. Scenario: on-prem docs sync hourly. Compliance requires weekly re-index validation. Design: DataSync runs hourly, incremental. Scheduled pipeline runs weekly, audits vectors, cleans stale entries, refreshes metadata. AWS loves this because event-driven plus scheduled, efficient plus compliant. Static+1, lock this in. Static, update rules, change detection logic, refresh schedule, target vector store. +1, change documents. Rules don't move, data does. That's Static+1. Ultra short exam cheat sheet: change doc re-embed, same doc skip, model upgrade scheduled refresh, bulk file migration, data sync, SFTP uploads, transfer family, permission change, metadata update only. Final memory story. The company archive room, incremental updates, only replace change folders, change detection. Red sticker equals reprocess, scheduled refresh, monthly archive cleanup, data sync, moving filing cabinets into the building, transfer family mailroom for external deliveries. No sane company reprints the entire archive daily.